Once again, greetings, incredible students. We are still doing past question paper, and the next question that we're going to be doing is still trigonometry, but we are now moving to it's functions. It's functions. My bad. I thought we were still doing trigonometric functions, but it's just functions. So, without wasting any more time, let's get to it. So in 5.1 we are told that sketch below are the graphs of f at x, and we can see that the graph of f at x, before we even go any further, is what we call a hyperbola. A hyperbola, which is a graph that has two segments or curve like that one, and the graph of g at x, which is a straight line, as we can see. Okay, and then excuse me, before maybe we go any further, we must understand one thing about the parabola, that it has values, x and y values in the Cartesian plane that it never touches, and we call those values the asymptotes. The asymptotes. Yes, so I just wanted to mention that. And then next, points A and B are the intercepts. Point A and B are the x-intercepts. Okay, so point A is the x-intercept of the hyperbola, and then point B is the x-intercept of the straight line equation. Okay, and then E is the y-intercept of G, the straight line. Okay, and then C and D are the points of intersection of F and G of these two graphs. This is where the two graphs intersect. And what do we know about the points of intersections of two graphs? Where the two graphs meet or intersect, those graphs are equal. So at any point, if we are asked whether maybe to determine the coordinates of C or D, we can simply equate the equations that we're given there, and then we solve for the x values and then for the y values respectively, because these two graphs at that point, or at the points of intersection, they are equal. So always remember that, just in case we are asked to do that. Okay, and then for 5.1 we are asked to write the y coordinates of E. We can see that it crosses there at the what you call that line, that dotted line there, is what we call the horizontal asymptote. It's the horizontal asymptote. So the y coordinates of E, we can just look at the equation. It's gonna be -1. It's gonna be -1. Okay, let's say maybe for any reason you forget that, okay, that dotted line is an asymptote, or maybe you forget how to read the asymptotes from the equation. You can also use the straight line equation, which is g at x is equal to minus 2x minus 1, and then we can see that the straight line there intersects the y-axis there at E, so x is equal to 0 at the point of intersection. So either way, so we know that x is equal to 0 at that point. So if we equate 0, x to 0, will be left with -1. Okay, let me put what I'm saying in writing. I said the y coordinates of E for 5.1.1 A, the y coordinates is equal to 1. This one is by identifying that what we have there is the horizontal asymptote. Let me put it in writing. Horizontal asymptote. But then E also just happens to be the y-intercept of the graph of G. So we can also calculate the y value of E by using the equation of the straight line, which is g at x. We say g at x is equal to -2x minus 1, yes. And then by using the y-intercept where x is equal to 0, so g at 0 is equal to -2 times 0 minus 1. Therefore y, which is our g at x, g at x is equal to -1, is equal to -1. Therefore, the y coordinates of E is equal to -1. So whichever method works best for you, but this one you are supposed to answer it just by observation, since there is only 1 mark for that. Okay, and then next we are asked to determine the vertical asymptote of f, the hyperbola. So just by observation you can see that the hyperbola doesn't touch the y-axis, and the y-axis are at the origin at where x is equal to 0, but also from the equation that denominator there of x, is not x minus something or x plus something, so it simply means that the asymptote will be 0 itself, so the asymptote for B will be x is equal to 0. That will be the vertical asymptote of f. Okay, and then next the coordinates of B is the x-intercept of G, is the x-intercept of G, so y is equal to 0 there at B. Okay, so we'll use the straight line equation once again. So it's 5.1.2 5.1.2, and we're saying B is the x-intercept of G, the graph of G. Okay, and then y is equal to 0 for the x-intercept, so we're gonna have 0 is equal to -2x minus 1. We have to solve for x. We're gonna have 1 is equal to -2 x. We divide by -2 on both sides. X is therefore equal to -1 over 2. X is equal to -1 over 2, and there you have it. Okay, and then what will it's just the coordinates of B, so we need to write both of them. Therefore B answer is not complete from there. B is 0 and -1 over 2. Those are the coordinates of B, the x-intercept. Okay, and then next we are asked to calculate the length AB. Okay, so in order to be able to calculate the length of AB, we need to also know the coordinates of A. And in order to find the coordinates of A, what is A? A is the x-intercept. A is the x-intercept of the graph of f. So for the x-intercept, y is equal to 0. Let's solve for the coordinates of A, and then we'll be able to calculate the length of B by using the x values. Okay, so without wasting any more time, this is our 5.1.3 f at x is equal to -2 over x minus 1. Let's double check as -2 over x minus 1, and then we are saying A is the x-intercept of f. A is the x-intercept of f, the graph of f. Okay, and then y is equal to 0 at that point. So we're gonna have 0 is equal to -2 over x minus 1. We put 1 on the other side. We're gonna have a +1 is equal to -2 over x. Then let's solve for x. Therefore x is equal to -2 by using the cross multiplication, of which this will make now the coordinates of A to be 0 and -2. Now that we have the coordinates of A, we can now calculate the length of AB. So in order to calculate the length of AB, we're going to subtract the way I presented the coordinates is incorrect. Yeah, I just noticed that I placed the x values in the place of the y values, so it's -1 over 2 and 0, and then here we're gonna have -2 and 0 because it's y that is equal to 0. Okay, and then from there let's calculate the length of AB just by subtracting these two terms. So AB is gonna be negative is gonna be, let's start with negative 1 over 2, the larger term, minus 2, and therefore we're gonna have negative 1 over 2 minus 2 is 1,543 over 2. It's gonna be 1.5 units. That's the length of AP. That's the length of AP. Okay, and then from there we'll also determine the coordinates of C and D, and there we have it, the thing that I was referring to at the beginning of this video, that the C and D at the intersection. I think in our statement we're told that points A and B are the C and D are the points of intersections. C and D are the points of intersection of the two graphs of F and G. And when we are calculating the coordinates, or when we are solving for the coordinates of those 2 points, we simply equate the two equations, because we know that both of the functions are equal at those 2 points, C and D. So let's go ahead and solve for that. So it's 5.1.4. Okay, it's 5.1.4. I think, let me copy this, and then, okay, so I just wanted to create some space for 5.1.4, whereby we are looking for the coordinates of C and D. 5.1.4, yes, the coordinates of C and D. So for 5.1.4, for the coordinates of C and D, f at x is equal to g at x, So what is the equation of f at x? Is negative 2 over x minus 1 minus 2 over x minus 1 is equal to the g at x is negative 2x minus 1 minus 2x minus 1. Okay, now let's solve for x. So we have negative 2x is equal to, let's add this 2x on this side, is gonna be, I think there was no need for that. Instead, let's just take the negative 1 on the other side. We're gonna have negative 2x minus 1 plus 1, which would be equal to 0. And then we're gonna have negative 2 over x is equal to negative 2x. Let's multiply by negative x on both sides. We're gonna have, when we multiply, we're gonna have 2 is equal to 2x squared. We're gonna have 2x squared, yes. And then I think after that, let's just divide by 2 on both sides to sort of isolate the 2. Therefore x squared is equal to 1, or maybe let me write it here, x squared is equal to 1. Okay, and then in order to solve for x, we need to introduce the square roots on both sides. And then remember that when we are introducing the square roots, we're going to have a positive and a negative root, So we're going to have two answers, which would make x to be equal to a positive 1 or x is equal to a negative 1. Now let's go back to our graph. X is positive in this side of D, therefore that one will go with the positive 1, and then we have to look for the y values. And then C, that is where x will be negative. C is on the negative side, so it's going to have a negative 1. And then to solve for the y value, we can use either of the equation, either the f at x or the g at x equation to solve for y. But either way, either one will give us the answer. So we'll just use a straight line equation and substitute the x values that we have right now. So we'll use g at x is equal to negative 2x minus 1. let's start by substituting. X is equal to 1, so g at 1 is equal to negative 2 times 1 minus 1, so it's minus 2 minus 1, which will give us 3. Minus 2 minus 1 is negative 3. So therefore we have those coordinates of d, which will be 1 and negative 3. And then next, let's substitute negative 1. So g at negative 1 is going to be negative 2 times negative 1 minus 1. And then therefore g at negative 1 is going to be negative 2 times negative 1 is equal to positive 2 minus 1 is just going to be 1, of which will make the coordinates of c to be equal to negative 1 and 1, positive 1. Those are the coordinates of D and C. Yes. For the completeness, let's also write here D is negative 3 and 1. And there you have it. And then next, we are asked to determine the values for which values of x for which the function of f is increasing. The values of f for which the function of x is increasing. Okay, so basically where it has a positive slope, the values of x, okay, for which the function of f at x is increasing. So since we are looking for the values of x for which the function is increasing, and we're saying where it has a positive slope, we can see that, okay, from negative infinity right up until 0, the function has a positive slope, so it is increasing for all of those values, but for 0, our function doesn't touch the x is equal to 0 value. And then also here our function is increasing, so from 0 to positive infinity, so both of these functions are increasing. If they were decreasing, they were gonna have this shape of that nature. Okay, so to put this in weights, it's 5.1.5a, 5.1a, 5.1.5a. So we are saying where x, we can say that is the element of from negative infinity to 0 using round brackets. Okay, or maybe let me put this one here, and then x is the element from 0, round brackets, since 0 is not included, to positive infinity, infinity. So that is where our function is increasing, where our function is increasing. And then next, for b, we are asked to find or determine the values of x for which the division between the two functions is less or equal to 0. Okay, so in other words, the ratio of this has to be negative in order to be less than 0. Start by dealing with that. And then to have a negative ratio, we can have a negative ratio if we have a negative g at x over a positive f at x, or we can have a negative ratio when we have a positive g at x over a negative f at x. Basically, that is what we should have in order to get a negative outcome for this. And then let's come here to our graphs. We can see that here from positive infinity to this point here, to that point A, the f function is negative, while the g function is positive. So a ratio between those two functions will yield a negative outcome, So any of the x values below a, what is the value of a? If we remember very well, value of a, we calculated the coordinates of a. Let me see, coordinates of a is -2 and 0, -2. So the coordinates of a is -2 and 0. It's -2 and 0. Okay, so for any of the x values which are less or equal to -2, the ratio of these two functions will be negative or equal to 0. Okay, and then next, oh no, not or equal to 0, no. And then another outcome, and then when we get here, the function now has positive values above the x-axis, while also the g of function is above the y-axis. So a positive and a positive will give us a positive. So all of those values here, they don't count right up until here at b, So for all those values of b here, and the positive values of and yes, and then the function of f will be also in the positive side. This is just above the x-axis. So it's those values and these values here that I highlighted initially. Okay, and then next let's look for areas, and then from there the graph of g is just below the x-axis, so it's negative, while the also the f function is negative. So a negative and a negative will give us a positive. A ratio between those two will be positive. So from there it doesn't work. So it's just those two areas, if I may say, two areas. Yes. Okay, so let's put this in weights now. So for all the values of x less or equal to -2, that's the first answer for B for values of x. So where x is less or equal to -2, we'll have a ratio between these two functions which is negative. Okay, and then the other values are there between b and 0, and remember that the function of f never touches 0. So what are the coordinates of b? B was -1/2 and 0. B is -1/2 and 0. So all of the values of x greater than -2 but less than 0 will give us a negative outcome here for the ratio of g at x and f at x. Okay, so let's come here. We are saying where x is greater or equal to -1/2, greater or equal to -1/2, but x is less than 0, because the function of f doesn't exist there at 0, so it's -2. Okay, so those are your two answers basically. Those are two answers basically for 5.1.5. And then if h at x is equal to f at -x plus 3, describes in weights the transformation of f to h. Okay, so in order to obtain the graph of h or h at x, we have to do those transformations, So firstly, we can see that x is negative now. So by changing the sign of the value of x, we are actually mirroring or flipping, yes, or flipping the function of f about the y-axis. We are flipping, so first thing first, the function will be flipped about the y-axis. So we can put that in weight. It's 5.1.6. So the function has been flipped about the y-axis, and then the second transformation that was made here, they added 3 units, so they also, so when we are just adding a number to the function like that, we are performing a vertical shift on the function. So this one has been shifted 3 units upwards, so that's another transformation that was done here, and is represented by that positive 3. So secondly, the function has been shifted 3 units upward. The function has been shifted 3 units upwards. So those are the 2 transformations that have been done on the function of f in order to produce the function of h. So this marks the end of our session. For these notes, you can check them on TikTok. Don't forget to subscribe and press a like and comment. Okay, thank you for watching this video.